Now, we shall see about resultant of several forces. In case if a body is subjected to several forces, then we can find resultant for those several forces. Resultant of forces is a single force that effectively replaces all other forces acting on the object without changing the external effects on it. Suppose you have a rectangular object. So, this rectangular object is acted upon by two forces. 10 Newton force pushes the object towards right and 5 Newton force acts in the other direction and it pushes the object towards left. These two forces can be replaced by a single force known as resultant. That resultant should produce the same effect as that of the two forces which are producing on this object. Hence, the resultant would be like this. Resultant of these two forces will be 5 Newton force which will be pushing the object towards left. So, if you see these two cases, the net effect on the object will be same. In the first case, you have two forces acting on the object producing a certain effect, and in the second case we have replaced the two forces by a single force known as resultant. This resultant will also produce the same effect as that of the two forces which were acting in case 1. Now, we shall see how to resolve a given force. As we discussed earlier, a force is a vector quantity and hence it has got both magnitude as well as direction. A force will be represented by a line. The length of the line to some scale will represent its magnitude, and also this line will have an arrow mark. This arrow mark indicates the direction of the application of this force. So, this is how we represent a force. Resolution of force is finding the components of a given force along two directions, namely vertical and horizontal directions. Suppose you have an inclined force acting like this. Resolution is nothing but finding the components of this inclined force along two directions, namely the horizontal direction which is x axis and the vertical direction which is y axis. Let the inclination of the force with the horizontal be theta. Vertical component of this force is represented by V and the horizontal component of the force along x direction is represented as H. So, vertical component is the component of the force along y axis or vertical direction, and the horizontal component of this force F will be along x axis and that component is denoted as H. Now, to find out the vertical component, let us consider this right angle triangle, this particular right angle triangle. In this right angle triangle, this is 90 degree. Now, for this right angle triangle, we shall take sine of the angle theta. Sine of angle theta will be, with respect to theta, V is opposite side. So, V divided by hypotenuse will be F. So, therefore, the vertical component V will be given by F sin theta. So, V will be equal to F sin theta. And in the same right angle triangle, if we take cos of the angle theta, then it will be adjacent side H divided by hypotenuse which will be F. So, therefore, the horizontal component H will be given by F cos theta. So, H will be equal to F cos theta. Now, if you see the direction of F, the force acts from this point, that is origin, and it ends up here. So, the direction of horizontal component should be towards right and the direction of vertical component should be in the upward direction. So, to reach from this particular point to this particular point, we have to move horizontally and then we have to proceed vertically. So, the direction of horizontal component will be on the positive x direction and the direction of vertical component will be on the positive y direction, that is in the upward direction. So, now we have found out the magnitude of vertical component along with its direction as well as the magnitude of horizontal component along with its direction. Now, we shall see a problem, we shall work out a problem, then we will all be having a clear picture about how to resolve a given force and how to find out the resultant of given force system. A particle is acted upon simultaneously by the following forces. Number 1, that is the first force is 200 Newton and it is inclined at 30 degree to north of east. Second force is 250 Newton acting towards the north. Third force is 300 Newton towards northwest, and finally, the fourth force is 350 Newton inclined at 40 degree to south of west. Find the magnitude and direction of the resultant. So, first of all we shall mark the 4 directions. North, south, east and west. The magnitude of the first force is 200 Newton and it is inclined at 30 degree to north of east. So, the first force is 200 Newton and it is inclined at 30 degree to north of east. So, from east it is acting at an angle of 30 degree towards north. So, this is the first force, we shall name this force as F1. The second force is 250 Newton which is acting towards north. The second force actually acts towards north, its magnitude is 250 Newton. So, this force is represented as F2. The third force is 300 Newton which is acting towards northwest. So, exactly between north and west we have the third force of magnitude 300 Newton which is F3. So, the inclination of this force with respect to west will be 45 degrees. Also the inclination of this force with respect to north will be 45 degree, because this force is acting along northwest direction. Finally, the fourth force is 350 Newton inclined at 40 degree to south of west, south of west. So, 40 degrees measured from west towards south. Magnitude of this final force is 350 Newton. So, in the problem you are asked to determine the magnitude and direction of resultant of all the 4 forces. Here the resultant R will be computed as square root of sigma h square plus sigma v square. So, this is the magnitude of the resultant, and the direction of the resultant is given as theta, which will be equal to tan inverse of sigma v divided by sigma h. Sigma h is the algebraic sum of all horizontal components of the forces, and sigma v is the algebraic sum of all vertical components of the forces. So, here 4 forces are acting, we need to find out algebraic sum of all the horizontal components of the forces as well as the algebraic sum of all the vertical components of the forces. Now, let us consider the first force, which is the force F1. This force is inclined at 30 degree to the horizontal. We need to find out the horizontal and vertical components of this force F1. The force F1 starts at this particular point and it ends here. So, from the final ending point, let us drop a perpendicular line. So, this particular value will be the vertical component of the force F1, and the horizontal component of the force F1 will be along the x axis and this will be H1. So, to reach from this particular point to end up here, horizontally we have to go towards right and vertically we have to move up. So, the direction of the horizontal component of F1 will be on the positive x axis and the direction of the vertical component of the force F1 will be on the positive y axis, that is in the upward direction. Now, H1 will be F1 cos 30 degree and V1 will be equal to F1 sin 30 degree. Now, the sign convention for the forces will be like this: all the forces going in the upward direction will be taken as positive and hence forces going in the downward direction will be taken as negative. Similarly, forces going towards right, that is along the positive x axis, will be taken as positive forces and forces going towards left, that is on the negative x axis, will be taken as negative. These are the sign conventions which we are going to adopt for our resolution. Since H1 acts towards right, sign for H1 will be positive. Since V1 acts in the upward direction, sign for V1 will be positive. Now, in the same manner we shall resolve the second force, which is the force F2. So, before that F1 is 200. So, it will be 200 cos 30. So, the horizontal component H1 will be plus 200 cos 30 and the vertical component of the first force F1 will be plus 200 sin 30. Now, the second force, actually it is a vertical force F2 whose magnitude is 250 Newton. Let H2 be the horizontal component of this force. So, horizontal component of F2 will be F2 into cos of theta. Theta here is 90 degree. Since the force F2 is acting in the vertical direction, theta will be 90 degree. So, if you substitute theta as 90 degree, H2 will be F2 cos 90 degree. So, which will be 0. Vertical component of this force will be F2 into sin 90 degree, which will be equal to F2 itself. The sign convention for the vertical component V2 will be plus, since this component acts in the vertical direction. So, V2 will be equal to 250 Newton. Now, the third force F3 is 300 Newton, which acts at an inclination of 45 degree from the west direction. So, the vertical component will be V3 and the horizontal component of this particular force is H3. Force F3 acts, that is, it starts from the origin and it ends up at this particular point. So, to travel from this origin to end up here, horizontally we have to move towards left and vertically we have to move in the upward direction. Now, H3, horizontal component of F3 will be F3 cos 45. Since H3 goes towards left, the sign convention would be negative. So, H3 will be minus F3 cos 45. Now, vertical component V3 will be F3 sin 45. If you see the direction of this vertical component V3, it is going in the upward direction, hence its sign will be plus. So, V3 will be plus 300 sin 45 and H3 is minus 300 into cos 45. And finally, we have one more force which is of magnitude 350 Newton. It is at an inclination of 40 degree from west. Now, we shall resolve this force along vertical and horizontal direction. So, this is the horizontal component H4 and this is the vertical component V4. So, the force F4 starts from the origin, that is origin is this point, and it ends up at the tip of the arrow mark. To travel from the origin to end up here, horizontally we have to move towards left and vertically we have to move in the downward direction. Now, H4 will be F4 into cos of 40 degree. So, it will be 350 into cos of 40 degree. Since H4 moves towards left, the sign convention will be negative. V4 will be F4 into sine of 40 degree, that is 350 into sine of 40 degree. If you see the direction of V4, it is moving in the downward direction, hence its sign convention will be minus. We shall find out the algebraic sum of horizontal components of all the forces. The horizontal component of the first force F1 will be plus 200 cos 30, which we have computed already. There will not be any horizontal component for the second force F2 and hence it will be 0. Horizontal component of the third force H3 is minus 300 into cos 45 and horizontal component of the final force F4 is minus 350 cos 40. So, if you do the calculation, the algebraic sum of all horizontal components of the forces comes as minus 307.04 Newton. Similarly, if we compute the algebraic sum of all vertical components of the forces, the horizontal component of the first force F1 will be plus 200 sin 30. For the second force F2, it is plus 250. Vertical component of the second force F2 is plus 250. For the third force, it is plus 300 into sine of 45, and for the fourth force F4, it is minus 350 into sine of 40. So, sigma V comes as 337.16 Newton. So, the magnitude of the resultant R will be square root of sigma h square plus sigma V square. So, if you do the substitution, the final answer would be 456 Newton. Direction of the resultant is nothing but inclination theta, which is given by tan inverse of sigma V by sigma h, which comes as 47 degree, 40 minutes and 36 seconds. So, we have computed the magnitude of the resultant as well as its direction.